Hello, with this example I'm going to explain you how we will calculate increase and decrease intervals of a real function. In this case the function is x cubed minus 3 times x. So the first thing is going to be always analyzing the domain, even it doesn't ask so, because we first of all need to know when the function is defined. This is a polynomial function, so there's not any real problem. Polynomial functions are defined everywhere. There's not any vertical asymptote, any kind of problem at all. So that's why the domain is R, the whole real line, or you could write from minus infinity to plus infinity, and you need to reason why is that, and that's because this is a polynomial function. Then we will calculate the first derivative and equal it to 0 because we want to see where's a change in the derivative. So we calculate the derivative and equal it to 0. And here we've got an equation. We need to solve the equation. And it happens that we've got two values here, x equal 1 and x equal minus 1. So at these 2 points, we've got critical points. Okay, we don't know exactly which kind of critical points, but it's for sure there are critical points. Then we will going to make the real line. We will locate these 2 points, and we will choose any value on the left side. Any. I've chosen minus 2, but we could choose minus 3, minus 100, it doesn't really matter. And we will replace this value in the derivative here. So we replace it and we obtain that the derivative is 9. It's not really important the value of the derivative. The only thing that matters is being it positive or negative. And it happens that this is positive. 9 is positive, greater than 0. So at all these values on the left side of minus 1, the first derivative is positive. And that's why I've drawn here an arrow going up. Then here in between, I've chosen the value 0. Okay, you can choose any. Replace at f prime the derivative, the 0, and it's minus 3, so it's negative. Again, it doesn't really matter which is the value. I mean, if you choose 0.2 and replace 0.2 in the derivative, I'm sure that the derivative is going to be different from minus 3, but it will again be negative, and that's what really matters, being it negative or positive. So we make the arrow going down. Then in this interval, I've chosen the value 2 and replacing f prime. And it happens that this is 9, positive, so the arrow going up. We've got a maximum over here, minimum at x equal 1. Okay, so I already know which kind of critical points they are. And I'm able also to write the increase and decrease intervals. Increase interval would be from minus infinity to minus 1, because these are always going up. And this is the union sign from 1 forward until infinity, because these are always going up as well. And then decreasing interval would be this one in between, okay, minus 1, 1. Okay. And if they ask you to calculate critical points, you need to give both coordinates. Okay, you know there's a maximum at x equal minus 1, but you need to calculate the second coordinate as well. So when x equals minus 1, and then you replace, in order to calculate the second coordinate, minus 1 in the function. So you go at the top and you replace there, and it happens that 2, so minus 1, 2 is a maximum, and when you replace 1, it's minus 2, so 1 minus 2 is a minimum. Points are points, you need to give always 2 coordinates. Okay, and using GeoGebra or any kind of program. If you draw the function, you'll see that okay, at -1 there's actually a maximum, at 1 there's a minimum, and you'll see that at all these points the function is increasing. Here it's decreasing and then increasing again. So this line would be the x-axis, and until -1 the function on the left side here, the function is increasing all the time. The derivative is positive. Here in between is decreasing all the time. The tangent lines are decreasing lines, and the derivative is negative, then positive. So yeah, it's really important you to realize this is the x-axis, okay? And everything really matches.